Hello and welcome to our very first video about our very first lesson in Math 1040, Introductory to Statistics at Snow College. This lesson is all about variables. It's really important. Let's get right into it. We're going to talk about two kinds of variables, two distinctions, quantitative versus qualitative. And it's a really important distinction that basically matters everything you do after you collect the data. Actually going to talk about data first. So what is or are data? You've probably heard data science or data. Data is just a bunch of facts or statistics about a set of entities that we can use to understand, explain, reason, and predict things about them. Within data are what's called variables. Variables is a specific measurement that we're measuring that describes a person, place, thing, or idea. And the key idea, or what makes it a variable, is it can vary from entity to another, one entity to another. That's why it's called a variable. It varies, which just means it can change. I'm going to pull up a data set that we're going to be looking at throughout the semester to understand these statistics topics, and we're going to use statistics to understand the data as well. And it's over here. This data set represents the population of all 2024 United States car models sold. And there's 1,220 different car models in the data set here. And each row represents an entity, in this case, a specific car. Here's an Acura Integra, and then the numbers and words to the right are the data for this particular car. Here's a different Acura Integra. It's different because it has a different engine size and a different transmission, all the things are different. So all of this together represents data. And I could keep scrolling, but I won't. Each row is an entity, and each column is actually a variable. So the displacement, that's basically the size of the engine, varies from car to car. Some of them are the same. There's a lot of 2-liter engines here. A lot of cars have 2 liters. But yeah, it changes from car to car. These ones are numbers. The transmission varies from car to car. A lot of cars have the same transmission, but these things vary. We might be interested in the gas mileage, which also varies from car to car. So each variable has, or each column is a variable, and you might notice there's different sorts of, or kinds of things that appear, like this one, fuel. These aren't numbers. These all say gasoline. Some say electricity. So we're going to use these data and these variables to understand cars in this example. There's two main types of variables, what we call quantitative or numerical. I like numerical because it's easier to remember, but quantities or numbers, these are data that have number measurements, and mathematical operations such as addition or taking an average have to make some sense. So a few examples are height, weight, temperature, and time. In all these cases, the measurements we would take would be numbers, and we could take an average and it would make sense. It would make sense to say, what's the average height of a bunch of guys? Or what's the average temperature for the month of whatever? What's the average time it takes people to run the marathon? Averaging is possible and it makes sense. Let's pop over to the thing over here. So I'm going to highlight the numeric columns. So they're all numbers, and also it makes sense to talk about the average gas mileage, or the average greenhouse score, or the average air pollution score, or the average engine size. So these are all numerical or quantitative variables. There's two kinds or distinctions within numeric variables. First, we have discrete, and we also have continuous. Discrete basically means it has a finite countable list of possible values. You could list them all out, you could write them all down. Even if it was millions of possible values, you could write it out. Basically, what you want to do is, can you find two consecutive values where there's no possible value between them? Then it's discrete. Here's a couple examples. The basketball score, a score of 60, let's say, and compared to the next possible score is 61. And you can't get 60.4 or 60.5 points in a basketball game. So there's only a discrete or a finite list of possible numbers for this score here. Same with your checking account balance. You could have 1 cent or 2 cents, but you can't have in between 1 or 2 cents. Continuous, on the other hand, has infinite number of values, and for any two possible values, there will always be a number between. One example is height. There's a caveat here. Usually we record height in a discrete way, but it's technically continuous. So I'm about 5'9.5". That's 69.5 inches. Someone else could be 69.4. We could go 69.45, 69.455, and we can just keep finding values in between. With infinite precision, there's technically infinite possible values of height. Any two possible values, we can find a value between by adding more decimal digits. So height and weight are classic examples of continuous, although technically they're usually measured and recorded in a discrete way. They're technically continuous. So that was numeric data. The other kind of data or variable is called qualitative or categorical. These are qualities or categories, and they're not numbers. Sometimes they are numbers, but basically, if they're not numbers, or if they are numbers but averaging doesn't make sense, they're categorical. So some examples: hair color, you could be, I don't know what that is, red, blonde, or brunette. Those are the options. There's probably more, but they're not numbers. Your favorite music genre: rock, country, classical, etc. That would be your particular value. Or your happiness level: low, medium, or high. These are all categories or qualities, not numbers. Some interesting ones, what might get you, are zip codes, phone numbers, and UPC codes. These are numbers, technically speaking, but it doesn't make sense to take the average. You can do it, but the answer doesn't mean anything. It's not meaningful. Like, you could take your zip code and my zip code and find an average, but that number doesn't mean anything, or the average of our two phone numbers. So these would actually be considered categorical data. So here's kind of a summary. Does an average make sense? Is it possible, and does it make sense? Yes, it's quantitative or numeric. No, it's qualitative, categorical. Let's pop back over here and just identify the ones I'm highlighting now are categorical variables. So the transmission, these are words. The drive, even though there's a number in it, it wouldn't really make sense to take the average here, or you can't even do it. We couldn't take the average of these two values, for example. Large car plus small SUV divided by 2. That doesn't even make sense. It doesn't even work. So we deal, the whole point of this is the statistics we're able to do, the graphs we're able to do, and statistics we're able to calculate are determined by the type of variable. What we would do with these things and these things, as far as understanding this population, is very different than what we're going to do with these things or these things. And we'll get into that later. So that's going to wrap up this video. We'll continue this lesson in the next video.